Good morning, class team. Let's continue our physics class. We had started a new chapter in the previous video, that is chapter number 8, electric current. Let us continue the same chapter. So far in this chapter, we discuss about the electric current, and then after that, we discuss about the mathematical expression of electric current, that is I is equal to Q upon T. And then again, further we understood that this Q, which is the charge, can be calculated by calculating the number of electrons flowing through the conductor. So that is why Q was equal to Ne. And then after that we discuss about the SI unit of electric current, that is ampere, and we also defined 1 ampere by taking the formula from the formula I is equal to Q upon T. Then we also discuss about the device which is used to the instrument used for measuring electric current, and that is ammeter. And we came to understand that this ammeter is always connected in series, okay, with the electrical appliances. So, and then now comes the next topic today, that is potential difference, electric potential at a point. Okay, before that, let me first write here that the electric current is the rate of flow of charge, that is Q upon T, and again Q is equal to N. So we get from here the mathematical expression, that is I is equal to Q upon T is equal to Ne by T, where N is the number of electrons flowing through the conductor and E is the charge of the electron, which is equal to 1.6 into 10 power minus 19 coulomb. The SI unit of charge is coulomb. The SI unit of current is ampere. We also discuss about the conventional direction of electric current, that is electric current always flows along the direction of positive flow of the positive charges, and then again we discuss that the flow of electric current is always against the direction of flow of electrons. And then in an electric circuit, we discuss that the electric current always flows from positive terminal to negative terminal. Okay, now let us discuss today another topic, that is potential, electric potential at a point first. Electric potential at a point. Electric potential at a point. Electric potential at a point. How to define? Electric potential at a point is defined as the amount of work done to bring a unit positive charge from infinity to that point. Now see here, you need to understand that the electric current will only flow, okay, when there is the potential difference. Okay, so that is why we need to clear this term potential. Potential means the energy possessed. Okay, how much energy is stored. Okay, like we know that the water always flows from higher level to lower level. Same way electric current always flows from higher potential to lower potential. So electric potential at a point means, suppose this is the positively charged particle, okay, positively charged particle, and then the space around it where it shows its influence is what we call the electric field. Okay, now what we are doing here is that we are bringing another positive charge from infinity, from far away, okay, to the point in this electric field. Okay, then what will happen is that, as we know that like charges repel each other, okay, so what will happen is that this positive charge, as soon as this positive charge comes in the electric field produced by this positive charge, then what will happen, it starts repelling, it starts pushing. Okay, so that time how much work done, okay, to keep this positive charge at a particular point in the electric field produced by this positive charge is what we call electric potential at this point. Okay, so how to define? Electric potential at a point can be defined by saying that it is the amount of work done to bring a unit positive charge from infinity to that point. Okay, so just now I explained about electric potential at a point. Now comes the SI unit of electric potential and mathematical expression. Okay, now let us suppose that W amount of work is done. okay, to bring a unit positive charge from infinity to a point. And then again the charge associated with this positive charge, let us take it as q, okay. Then the potential difference, which is denoted by V, is mathematically given by W by Q. So this is the mathematical expression of electric potential at a point, that is V is equal to W upon Q. And the next thing is SI unit. The SI unit of electric potential is how much? Volt. VOLT, volt. And then again this volt is denoted by capital V. Okay. So from here you can be asked about define 1 volt. Okay, that time how to define this volt. So 1 volt can be defined from this expression. Okay. Now as we know that V is equal to W upon Q. So when the amount of work done is 1 joule and the charge is 1 coulomb, then the volt will be how much? 1 volt. Okay. So electric potential at a point is said to be 1 volt if 1 joule of work is done to bring a unit positive charge of 1 coulomb from infinity to that point. Okay, this is how you can define. So electric potential at a point is said to be 1 volt if 1 joule of work is done to bring a unit positive charge of 1 coulomb from infinity to that point. Okay, so this is how you can define volt. Then after that comes the measurement of electric potential. Okay, let us first complete potential difference. Then we will discuss about the instrument for measuring electric potential or the potential difference. Now potential difference between the 2 points. Potential difference between the 2 points. As I told you that the electric current will only flow if there will be difference in the potential between the 2 points, okay, of the conductor. Between the 2 points of the conductor, when there will be difference in the potential, then only the electric current flows. And electric current always flows from higher potential to lower potential. In an electric circuit, the positive terminal is always said to be at higher potential and the negative terminal is always said to be at lower potential. So that is why in an electric circuit, what happens is that the electric current always flows from positive terminal to negative terminal. Okay, this point you need to remember. Now potential difference between the 2 points. If you are asked about like how to define this between potential difference between 2 points, now how to define it? Now potential difference between the 2 points is the amount of work done. Suppose this is one point, this is another point, this is A and this is B. These are the 2 points on the in the conductor. So the potential difference between the 2 points of the conductor is the amount of work done to bring a unit positive charge from one point to another point. Okay, it is the amount of work done to bring a unit positive charge from one point to other point is called the potential difference between the 2 points. If we suppose the potential difference at this point is VA and at this point VB, then again the potential difference is given by VA minus VB is equal to how much? W by Q. Okay. The SI unit of potential difference is also volt. Okay, is also volt. And then the instrument for measuring this potential difference in the electric circuit is instrument for measuring this potential difference is voltmeter, which is always connected parallelly. This point also you need to remember, connected parallelly in the electric circuit, parallelly in the electric circuit. Like suppose this is the bulb and it is connected to a cell. Okay, this is positive terminal which is represented by long line and the shorter line represents the negative terminal. Okay, this is the symbol of a cell. Now here in this case what happens, electric current flows from positive terminal to negative terminal. Okay. Now the voltmeter, which is denoted by V, this way. This is the symbol for voltmeter. In the electric circuit we use this one. Okay, ammeter for ammeter, round A, you might have learned all this thing in class 9 also. Okay, ammeter, voltmeter. Okay, voltmeter is always connected in parallel with the electrical appliances. The reason is that this voltmeter usually have high resistance. Okay, if they are connected in series, then what will happen is that large amount of current will flow through them, and it leads to heating effect. Okay, due to its high resistance, large amount of heat is produced. It may spoil the device or the instrument, so that is why it is always connected parallelly to the electrical appliances or in the electric circuit. Okay, so this point also you need to remember. So just now we completed electric current, and then after that we completed the potential difference for the electric potential at a point. Okay, now after this next topic comes, that is Ohm's law. Ohm's law. Okay, how this Ohm's law tells us how the potential difference applied across the conductor, okay, is related to the electric current flowing through the conductor. Okay, how they are related to each other. So this relationship is given by Ohm's law. So from here you can be asked straight Ohm's law. Ohm's law. Okay, Ohm's law states that the current flowing through the conductor, how much amount of current is flowing through the conductor, okay, is directly proportional to the potential difference applied across the conductor. Means more the potential difference you apply, more will be the flow of electric current. Okay, provided the physical conditions such as mechanical strain, pressure, temperature always kept constant. Okay, because it may affect this one, the temperature, pressure, mechanical strength, this all may affect this relationship. Okay, so that is why while defining the Ohm's law, you need to say that Ohm's law states that current flowing through the conductor is directly proportional to the potential difference applied across the conductor, provided the physical conditions such as temperature, pressure, mechanical strength are kept constant. Okay, so if suppose the potential difference applied across the conductor is V and the current flowing through the conductor, okay, is I, then according to Ohm's law, what we know is that according to Ohm's law, what we know is that V is directly proportional to I. More the potential difference you apply, more will be the flow of electric current. Okay, then again next, when you remove this proportionality sign, then what happens? The constant of proportionality comes, which is denoted by capital R. Or the same thing we can write like this, V is equal to IR. Okay, where this R is the constant of proportionality. This is the constant of proportionality. Constant of proportionality, which we call resistance of the conductor. Called resistance of the conductor. Now here in this case we are introduced to another term, that is resistance. After this we will discuss about what exactly is meant by this resistance. Okay, so just now we derive the mathematical expression. This V is equal to IR gives the mathematical expression of Ohm's law, and then again it gives the relationship between potential difference and the electric current flowing through the circuit. Then after that, so let us try to know about the resistance. Okay, resistance. What is resistance? What is SI unit? Okay, resistance is actually the obstruction offered to the flow of electric current. Okay, when the electric current flows through the conducting wire or any conductor, then what happens is that the flow of electric current is obstructed. Okay, this obstruction offered to the flow of electric current is what we call resistance of the conductor. Okay, so resistance is simply the obstruction about to the flow of current. Obstruction offered to the flow of electric current. To the flow of electric current. To the flow of electric current. Okay, it is denoted by capital letter R. Okay, its mathematical expression is capital R is equal to, from Ohm's law we can write C. From Ohm's law we know that V is equal to IR. So R will be equal to how much? V upon I. Okay, its SI unit is ohm. Okay, and the symbol of this ohm is, it is written by omega like this. Okay, ohm. Now from here you can be asked to define 1 ohm. So that time how to define? Okay, define 1 ohm. So with respect to this mathematical expression, we try to define 1 ohm. So define 1 ohm if you are asked, then what you need to write is that we know capital R is equal to V upon I, and then again when this resistance will be 1 ohm, when potential difference will be 1 volt, and then again, and the current flowing through the conductor is 1 ampere, then the resistance of the conductor is said to be 1 ohm. So 1 ohm is defined as the resistance of the conductor when the potential difference, when 1 volt of potential difference is applied across the conductor and the current flowing through that conductor is 1 ampere. Okay, so you can also define by saying that when the potential difference of 1 volt is applied across the conductor and the current flowing through that conductor is 1 ampere, then the resistance of the conductor is said to be 1 ohm. Okay, so this way you can define 1 ohm. Then after that we need to discuss about the ohmic conductor and non-ohmic conductor. Okay, that we'll do in the next class. Let us keep up to here. Thank you very much, students.